Sometimes our expressions are written not with an equals sign, but with a greater than sign or a less than or something like that. For example, sometimes we might find that we have our expressions written like this. Now, because we don't have an equal sign there, it's called an inequality rather than equation. And this means y is greater than x. And the way I remember that is because towards the y you've got 2 points, whereas towards the x you've only got 1. And y therefore is bigger than x. Now when y is greater than x, that doesn't just talk about a line, it talks about an area on the Cartesian plane. So all I'm looking for here is an area where the y coordinate is bigger than the x coordinate. For example, if I draw the line, and I'll start with the line y equals x, I'll draw that in and it looks like this on my Cartesian plane. Now, if I have a look at a coordinate that is over here, this might be a coordinate that's something like 2 and 5. When I look at each of the different numbers, I can see that y, which is 5, is bigger than 2, which means this point satisfies this rule. If I have a look somewhere else, let's imagine here, this might be the point at 3 and negative 3, I can see my y point here is less than x. This doesn't satisfy the rule. So when I'm looking at an inequality like y is greater than x, what I'm looking for is the area that satisfies this rule, which in this case is going to be the orange area. So all of this area satisfies the rule. But what about the blue line? The blue line here that we've explored is a boundary of the line. Now, here I have a sign that's saying y must be greater than x, which means the blue line actually isn't part of the rule, because the blue line isn't where y is greater than x. The blue line is where y equals x, which means the blue line's not included. The way we show that there is a line and it's not included is by drawing a dotted line. This dotted line means it's not included. If the line was solid, let's say I was going to draw y is greater than or equal to x, then the line y equals x is part of it, which means we would draw this line as a solid line and then shade the desired area of the yellow part. And all of this area here satisfies this rule. So in summary, an inequality is when we have an expression that might be y is greater than, or here y is less than x, y is greater than x, y could be less than or equal to 3x plus 4, y is greater than or equal to a half x minus 6. Any sort of expression that we could have had with an equal sign where we now have some element or greater than or less than is an inequality. Remember, what we do is we check to see if the point is or isn't in our region. And my inequality sign is all about an area on the graph rather than a straight line. And finally, when I have an equal sign, I'll have a straight line that's unbroken. When I have an an inequality that doesn't have an equal sign, I'll have a dotted line that is broken to show that that line is not included in the area. Just like simultaneous equations has two lines on the same Cartesian plane, you can have two or three or more inequalities at the same time. So for example, if I had an inequality of y is greater than x plus 4, and I had another inequality of y is greater than or equal to 2x. I could draw both of these on the Cartesian plane and find out which area was common to both of these rules. So let's do that. X plus 4, remember, if I sketch y equals x plus 4, and then remember I'm going to test, and then remember my area is not included in the line, then I can sketch that. So y is x plus 4, that's going to look something like that. Now I know that if I can test a point, so let's test a point that's up here. Let's imagine I'm testing a point at 0 and 6. If I am correct and if this point is in the area, then 6 is my left-hand side, which is y. My right-hand side will be 0 plus 4. Now, for my rule to exist, 6 must be greater than 0 plus 4. 6 is greater than 0 plus 4. So therefore, this is the area that we can call our blue area. Finally, we don't have an equal sign in this inequality. It's just greater than. So therefore, rather than have that blue line the way it is in a solid form, I need to make it so that it's dotted. So here we go, making it a dotted line. And now I've correctly identified the region of y is greater than x plus 4 by showing the equation of the line and then shading in the appropriate region. And really, I should include my intercept as well. Now for the yellow region, I'm looking at the area of y is greater than or equal to 2x. So that's a line that's going to look something like that. So I'm going to draw that line in. The next thing I'll do is I'll test whether a point is appropriate. And let's now test the same point. We can test the point 0 and 6. If I'm looking at the point 0 and 6, then my left-hand side would be 6. My right-hand side would be 0. 6 is greater than or equal to 0. So that means the point at 0 and 6 is in the region. And that means this point would be in the region. So therefore, this is the appropriate region for the yellow area. And finally, what we can do is combine them to find out that this region here has both. So therefore, I'll have a region where I have a dotted line, which is green there, and I have a solid line from the point of intersection. And my area that I'm interested in is this green area, which is in here. The final thing I would want to do is find my point of intersection. And that point of intersection will be at 4 and 8.